Hello everyone and welcome to this video. I am Ayush and in this video we are going to discuss the most important Python library, which is Numpy. So this Python library is used for maths operations such as algebra and statistics. So without any further delay, let's get started. Alright guys, so now we are going to discuss the most important Python library, which is Numpy. So we are going to use this for basic mathematical operations, and even you can do statistical analysis, complex maths such as trigonometric and linear algebraic expressions. This we are going to discuss. I'll come to that point as well. Let's move to the next slide. So here, what is NumPy? So NumPy is a fundamental package for scientific computing in Python. So it's a fundamental package. It's a Python library that provides a multi-dimensional array. I'll come to this point as well about multi-dimensional arrays, object various derived objects such as masked arrays and matrix, and assortment of routines for fast operations. Here you can do very fast operations on arrays, and you can do lots and lots of things here like sorting, selecting, discreting, and then basic linear algebra, basic statistical operations, random simulation, and much more. So let's go to the next slide. So why to use NumPy? Why use NumPy? So here main 6 things provided here. One by one, let us read. So first thing is NumPy provides efficient storage. So what when I say efficient storage, what do I mean by this? So efficient storage means now you must be familiar with bits and bytes. So if example I created a list L1, let me name this as L1, and here if I give Python to save this, so it'll take more bytes to save it, 64 bits it'll take to save this example. So this is quite big bits because this is very long bytes. First to save just a example, you have one digit numbers, so one digit number saving 8 bit is more than enough. So now if we use NumPy, you can specify how much bits it should take. Normally it will take 32 or 64 bit, but if we specify like example I want just 8 bits. Now if I create L2 using NumPy, so here it will just take 8 bits instead of using 64 bit. So there is lots and lots of difference between NumPy and Python libraries, and it's good for data processing and handling data because yes, we use array for faster calculations because it's super fast and it's easy to learn, and it uses less memory. Again, the first point and fifth point are almost the same. Then sixth point is it can be utilized to perform a number of mathematical operations on arrays such as trigonometric, statistical, and algebraic routines. So this you can we'll discuss. I'll come to this point as well for maths operations in NumPy. So now next thing is how to download NumPy. So it's a quite straightforward. So if you're following this course, you will be having Anaconda downloaded. So if you're using Anaconda, NumPy will come pre-installed in your machine. But in case you don't get pre-installed, if you're using older versions, then you can just run a command, simple command, conda install. Instead of this pip, you can just use conda. So you can just use conda here instead of pip to install NumPy. But most of the cases, yes, it will come pre-installed, but by chance, by some reason, NumPy did not come, you can just use conda. But if you have downloaded this NumPy through python.org, or you are running through cmd the terminals, then you should run the command pip install NumPy. So using pip you can install the NumPy. Pretty straightforward command. Just write it and just hit enter and it will be downloaded for you. So now let's go to the main part, which is the coding part of this video. So first thing, in order to do any library, no matter it's only NumPy or Panda or sklearn or PyTorch or anything, anywhere if you need to use a library, first you need to import. So it's very easy to import. Just you need to write import NumPy as np. So this np is kind of alias. This we say it as alias. So what does this do? Like is a just kind of short form of NumPy. Throughout the program I need not to repeat this NumPy again and again. instead of repeating numpy again and again, I can just write np throughout my program. So this is a more efficient way. So what we do here, we have just imported numpy, which is the package which we are going to learn in this video. Alright guys, so now let's discuss about arrays. So first let me import this. Now if this is successfully run, so numpy is successfully imported. If it's giving you error, just you can look into it. So let me run the all cells once so that it can get number 1. Okay, so now let me create an array. So what is this array? So first let me create it. My array equals to np dot array, and here I'm going to give a parentheses and here pass along a list. Now let me give some even numbers 2, 4, 6 and 8. Just for example, let's run this. Okay, here instead of np I wrote mp. Run this. So this is np, and here this we have used numpy. Or if I was not writing this as np, so here I needed to replace this np with numpy. I need to write again numpy dot array, numpy dot min, numpy dot max. So instead of repeating it, repetitive process, just np, a short form. So let me view my array. Run this, and here my array is 2, 4, 5, 6, 8. So this is a very easy way to create a numpy array. So this numpy array, here we have used a Python object or structure which is list. So in the starting I have explained you get a very nice memory management in numpy. So when I said that, what do I mean by that? So here if I write numpy dot int, why did I write int? Because this is the data type of these numbers are int, and next I'm going to write 8. Now this will save this numpy array with d type as int 8, means at 8-bit this will be stored. So 8-bit is a very less memory compared to 32 or 64. So here 8-bit it will take we have written it has taken 8-bit. But one more drawback is like if I write 600002, run this and run this will give me minus 62. Now this is the kind of error because it's not the same number which we have written here. So 8-bit supports only small numbers, not big numbers. So if you're having a little bit big numbers, so here you can write 32-bit. This is also another bit, so it's taking. Now it's a very big number, so for that it's 64-bit, and it bit increases and decreases. So basically we use just 8-bit or 32-bit or 64-bit, any three of any one we normally generally use. But if you want, if your numbers are short, example if I convert this back to 6, so this 6, 2, 4, 6 are just 1-digit numbers, so I don't need 8 bits or very big bits. Here just small 8-bit is more than enough, but we are going to do lots and lots of thing in this array, so we need 64-bit. Run this, and here this is 64-bit. So this was all about array. Now let's recap. Array is we use array, it's a numpy array, so we can use Python structures, lists, tuples to make an array. It's a kind of it's almost same to the list, but the thing is that it will be of same type. Like if you make a list, my array list, so here only list should be there. If you want to add a tuple in this, you can give a comma and make it into 2D array or 3D array. What is 2D array? So just you can say, can kind of think of two lists inside one array. So here if I pass along another, which is, let me take odd numbers 1, 3, 5 and 7. So this is a 2D array. This is one array and this is one different this is one list and this is separate list. Both are different lists, but here we have just but it's all inside my array. Let's run this. Okay, so let me remove this first. Just let's take a simple 2D array. Here we need to kind of here we can write it like this. So there are different types of arrays 2D array, 3D, this we are going to discuss by like it's the other part of the video. This point I'll come in the next part, but here for now you can understand array is a kind of same data type we use. It's equal to list, almost same to list, but here it's through numpy. Okay, so now we are going to discuss about next thing is how to access an element in an array. So this is we have created an array. Just let me remove this part. Okay, so now if you want to access an element, I need to give 0 comma 1. So what is this 0 comma 1? 0 comma 1 is the indexes which we already discussed. So this will give me an error. So what is this error? So let's just take it in this array form. 0th column. So 0th column is obviously this. First is now the zero, there is no 0th comma 1 row because there is it's a 1D array. So here instead of 0, if I write 0, instead of 0 comma 1, if I write 0 just, so this will take the 0th index element, which is 2 here. But this error is 1. I'm getting 1. So why is this error? So here we need to write 2D arrays, something called as 2D arrays. So what does this 2D arrays do? This 2D arrays is like kind of a nested list, a nested array. So here there is two different lists here. So now if I run this and check, now I'm getting 4. So at 0th comma 1, this is there. So 0th at 0th, just because at 0th column is which is this list. This list first index element is this is 0th element, and this is the first element. So this first element has the index of 4. So in this way we can access the elements. But what if I remove this? So this will happen the same thing. I need to remove this as well. Let me remove this from here also. Run this, and here if I put it 0, run this will give me 2, just 1. So this is kind of accessing the elements through using their index. So here we give the index values, and if once I pass along the index value, I'm going to finally get my result. So if I want to know more about this array, the two main functions which we use is shape and dtype. So first thing is my array dot shape. So actually what this will do, this will give me kind of this my array dot shape will give me how much the length is this array is having. So now this is 4 comma and there is nothing here, like it's 0. Let me first convert this into a 2D array. Okay, it's a 2-dimensional array. Here I'm going to get an error obviously because this is I was having, this is a 2D array. Run this and this you'll get 1 by 4. So 1 by 4 means 1 column and 4 rows, and my array dot d type, and if I run this I'm going to get int 64. So automatically this has taken int 64. I have not set here which type of element I need to here. Example np dot int 8. If I pass along, run this, then it is going to give it 8 int 8. So it's saving at 8-bit. But normally if we leave it blank, so this will automatically save at int 64. So there is int 8, int 32, int 64, float 8, float 32, float 64. Float is fractional numbers, like example 2.0. And here I can use float 8 or float 32, float 64. So let me run the cells all once again so that this will get the correct numbers. So first we imported it, import the numpy and my array. Here is we created an array, and this is a 2D array because there is two lists, and then the first list is this list. Here we have some even numbers, 4 even numbers, 2, 4, 6 and 8, and this second one which is outside of the first list is blank because there is nothing, no values in it. Then we have discussed about this my array dot shape, which will give the shape of this array, and then my array dot dtype it will give you the whether which type of D type it is, like it's running on 8-bit or 32-bit or 64-bit. So the next thing which we are going to discuss here is how can it change a particular element. So example, if I take my array and at 0 comma, here let me give 0 comma 1, so here it's 4, so obviously because at 0 comma 1 there's it's 4. So now here at my array 0 comma 1, if I set it as equal to 12, run this and view my array, here I'm going to get, instead of before it was 4, now it's converted into 12. So this is how you can change. Just to give equal to 12, first you need to specify the index value. What is the value? Is it 2 or is it 4 or is it 6 or it is 8? So set the index value first, and then you need to write a equal to sign and then give out the whether what is the number, final number. Here I gave example 12. If I view my array, here instead of 4 it's been changed to 12. Alright guys, so now we are going to discuss about array creation methods. So but before that, once you go to the documentation of Numpy, so here the Numpy and Sci-Fi documentation is very big. You can see it's very big. Now if you start reading these documents, this will take lots of time, but normally generally what we do, we learn Numpy for just for data analysis or data science, max to max data science or data analysis. But here it's a very big guide, so learning each and everything will make you an issue. So in this video we are going to discuss about those portions only, which is Numpy portions which you need for data analysis and data science. So that will be more than enough, because if you start reading whole documentation, lots and lots of issues will come in your way. So before so we are not going to cover whole Numpy, because this even the video will become more than 50 hours of video, and making 50 hours of video is kind of impossible. So and it will be very long. So instead of that, how much ever you need for just for data analysis and data science, today we are going to cover that in this video. Okay guys, so now let's discuss about the array creation methods. So you should head over to the google.com and search for array creation methods in Numpy. Hit enter and you'll get a documentation from numpy.org. Just click it and here you'll get array creation methods. So first thing is the introduction. So there are 5 general mechanisms for creating an arrays. Conversion from Python structures, example lists and tuples. This is meant by the first point. So this we have already discussed. Here we used a list to create an array. We can use tuple also to create an array. The next thing is intrinsic NumPy array creation objects. We can example arrange ones, zeros. This point I'm going to come back. I'm going to come back to this point as well. Then reading arrays from disks, either from standard or custom formats. This we can take from our disk the data and do the analysis in the NumPy. This point also I'm going to come. Creating array from raw byte. This is something like the third point only. And use of special libraries function, example random. We can use numpy.random, and there are many more attributes and more functions which are going to use. This point also I'm going to come. Then we are going to discuss about some attributes, models, and some models, attributes, and some functions. And then we are going to discuss about the axis, and that much will be enough for this tutorial, because we are going to just discuss the NumPy for data science and data analysis. Now if you want a full all detailed everything should be detailed, each and everything, you can just you can go, as you can click here, and this Numpy documentation is open. You can go to user guide, what is Numpy installation, quick start, the absolute beginners, basics. From basic to the advanced level, high level, you can discuss, so there is no tension. So if you want to discuss example basics, you can go to basics. Then if you want to learn broadcasting, you can click broadcasting, and then here with the examples they are there. But today we are going to discuss NumPy for data analysis and data science. Okay guys, so the first thing here, let's go one by one. First thing here is conversion from other Python structures, example lists and tuples. Let's come back here. Conversion from other Python structures heading is given. Now let me create list array equals to variable. So numpy dot array, and let me create a 3D array. Now what is 2D? Now what we discussed 2D, just 3D is one more list. So here let me write 1, 2 and 3. Let me pass along another 4, 5, 6, and let me give another which is 7, 8, 9. So basically in data analysis and all, let me change this back to n. So in data analysis we use either 1D, 2D or 3D. Max to max we use 3D, not more than that. So if you have knowledge till 3D, it's more than enough. So let's run this, and if I check inside my list array, here we have our list and array 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is kind of in a form of rows and columns. So this is what we called as matrix. Now so what is matrix? So here I have set of numbers. Here you can see the set of numbers. Now what if I take this numbers and convert it in a form of rows and columns? I give these numbers some row and some columns. So I give some rows and columns to this set of numbers. So this whole thing, when it comes finally, this is called as matrix. Now this is a simple even array. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now for if you want to know more about this list array, here I can write list array dot d type, which is taken at int64. List array dot shape, here I'll give 3 by 3, 3 cross 3. Here you can see 3 by 3. So next thing is list array dot size. Run this. This will give the size. How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are totally 9 characters. So this was basically how can you use list array. Here we have used list array, created a 3D array, viewed it, discuss about the matrix. Matrix is kind of set of numbers, converting the set of numbers to rows and columns. Some row or a column, you can convert it to a row or a column, so that you can use it. So that is good for better analysis. So once the thing is inside a form of a rows and columns and it's neatly explained, neatly organized, so at that time you can do better data analysis compared to if it is scattered. Next we have d type dot shape, which is 3 cross 3, then int64, and then dot size is for 9. Okay guys, so the next thing which we are going to discuss, now we have already discussed this conversion from other Python structures. Now we are going to discuss our interesting Numpy array creation objects. So what is this an interesting Numpy array creation objects? So this is, you can think it kind of built-in functions. So these are some kind of built-in functions which is provided by Numpy. Let's look into it. Here I have created a heading in interesting Numpy array creation objects. So let's take example. I create a variable which is z rows. Here I equals to, and here I'll give numpy dot zeros. So the zeros, as we have discussed, the not discussed here, zeros is a kind of built-in function provided by Numpy. Here I want to pass along how much by how much should be this zeros, this array. Let's run this. Okay, so here I need to give another brackets. So okay, here I need to give this bracket. Okay, so here numpy dot zeros, here I need to give two brackets. From one bracket it won't work. So here zeros, numpy dot zeros. Now if I watch what is inside my zeros, so this will be 0 0 0 and here 0 0 0. So this is 2 by 5 matrix. It's been created of zeros. So 2 by 5. Now here we have defined the numbers, that should be only 0. And what is the matrix? 2 by 5. So 2 by 5, it's been created. Here everything will be 0 only, no 1, 2 and your numbers, normal numbers. So here I can give dot shape. So this will give weights 2 by 5. If I check here d type, this will be float 64, not int 64, because 0 is not an integer, it's a float. And if I convert it back to zeros. This will be 0 by, is 2 by 5, only zeros. Okay, so the next thing which we have discussed with zeros, and next thing is a range. Let me come back here, and here for a range example we have already discussed in our Numpy tutorials. In the Python tutorials we have discussed about range functions. Range is like we define some number to that number, fixed values, that in between those numbers whatever numbers comes, this it will print for you. So let me create some variable which is a rng equals to numpy dot a range, and in a range I'm going to pass along example 15. Let me give me 16. Run this a range. If I copy and paste it and run this, this will be 0 1 2 3 4 up to 15. Now we know the thing which is it's up to and excluding the numbers. Now many people ask like why up to and excluding the number, because the numbers start from zeros. Now normally we start counting from 1, so if you start counting from 1, so the 16 where you can count till 16, because one number is added from 0, so one number gets cut from the end side. So this is 0, then 1, and it goes on till the 15. So it's up to and excluding. So if I remove this 0, and from 1 if I start counting, this will be correct how much ever we write here. But normally in programming we start from 0, so 0 to 16. So this is all about a range. Alright guys, so the next thing which we are going to discuss is linspace. Let me create ls variable, and here let me write np dot linspace, and here if I pass along, so I am going to pass along some numbers, example 1, 5 and 4. Run this and let's check what is inside my ls. This will be 1 point some blank zeros, then 2.333, 3 points some decimal values, and 5. So what did this linspace do? Now you need to hear this carefully. So here example, this is the starting element. We have to define some elements. First element, what does it do? Just it takes a 1. So the starting value, now our starting value should be 1. I defined it. Second thing will be our next value, the ending value, last value, what should it be? So here there is no up to and excluding the numbers. It's like if you write it that much itself, it's going to give. So 5 if I write, so this will give a kind of range from 1 to 5. Then 1 to 5, how much numbers, how many numbers should be there totally? There should be totally 4 numbers. Between 1 to 5, give 4 numbers and give equal spaces. Now between two numbers, the space it should give some space. That space should be equal spaces. So at equal spaces is going to leave and move ahead, give equal spaces and move ahead, and when it moves ahead, we need to specify how much number should be there here. So here should be 1, and this is the second, this is the 3, and next 4 elements. So there are totally 4 elements are requested here. Then between 1 to 5, it's printing from 1 to 5, and between 1 and 2, the space, there is some space, because 1 point if it is blank, think it as 0. So here it's blank. So between this and this, the space which comes, the same space it's going to give from 2 to 3. Between this 2 to 3, how much spaces it's going to come, the same space it's going to give, and the same space which is given from 2 to 3, same space will be given from 3 to 5. Hope you have understood. If you have did not understood, watch it again and again. You're going to understand this thing. It's kind of complicated, but yes, if you understand this, because this is very important when you go for linear algebra or mathematical problems, if you are going to do, so linspace will work best. Okay guys, so the next thing which we are going to discuss is something called as not linspace, empty. So empty is kind of it will give you an empty array. So let me give you examples for better understanding. Let me create a variable emp equals to, and here I'm going to write numpy dot empty. Here numpy dot empty, and here I'm going to give along how much by how much, so it should be 4 by 6. Okay, so emp, so here np, run this emp. If I view my emp, emp run this will give me just random numbers. It will be a random numbers, not like I need to specify 0. This is a random number, any point decimal, it's just random, plus 000 random, it's generated from any number. They I'm not even specified like it should be between 1 to 5 or it should be number from 5 from 0, nothing I have specified, just an empty array, kind of empty array with some random elements. Now if you want something like example this to be if now you can assign some value like this value. If I want to change, you can assign the value as we have discussed in starting, using the indexes and indices. We can change this element. This is kind of empty array, you can use it. So this was all about empty. Alright guys, so the next two things which we are going to discuss is empty like. So what is this example? If I write emp underscore like equals to, and here I'm going to write np dot empty underscore like. So I need to give underscore like, and here I'm going to pass along any array which you have already created. So ls, this is the array which I have already created. This is just for example. If I view my emp, let's so here if I view, this is just the same thing again, this whole things are same. So what does this do extra? This is kind of copy. This whole array it has just copied and put it inside another variable. This kind of view of this array. So this is what empty like. Next thing is IDE, identity. So ID equals to, and here if I write np dot identity, and here I want to write 45 or let's say 35 for example. Run this, and IDE if I write, so this will be kind of 45 by 45. It has created an array of ones and zeros, just ones and zeros. Now if I check its shape, so this will be 35 by 35 because it's 35 by 35 it's created. So this is IDE. So this is just for better efficiency. Now if you are familiar with linear algebra in maths, so you must be knowing this identity. This way it's the part of linear algebra. So this identity is kind of the same thing in algebra. 35 by 35 thing it's created, 35 by 35. So here is random values or ones and zeros is also filled, and this empty like just is a copy. It's for just for better efficiency. Alright guys, so the next thing which we are going to discuss is reshape. So this is very important, so focus this. ARR is equals to, and here if I write np dot arrange, and here if I specify 99 and run this and view my ARR, nothing will happen, just 0 to 98 means 99 elements. But what will this reshape do? Here this ARR dot reshape, and reshape by 3 by 33. Okay, so here I'm going to write 30 has no, okay, spelling is wrong of reshape. Did I write shape, reshape? Run this. Okay, so this is done. So here what does it do? It creates like a how much ever you specify first thing, like first index I have specified it for 3, so it will kind of create 3 lists here. Now I need to fill the elements, right? So here it should fill 33 elements in each of the lists. So here 33, here 33, and here 33 elements. All 33 elements will be equally divided in 3 different lists. But here if I change it to 31, I'm going to get an error. So what is this? Why is this error coming? It can divide 31 equally, but when I say equally, it should be equally divided. I said equally, but here 31 means this will not be divided. Now if 31 times 3 is not 99, but 33 times 33 is 99. So it will divide equally. Now if you're familiar with maths, in maths if you want to divide it equally, we need like if we multiply this will be, and we should get this answer only. So if we get this answer, this will be equally divided, so no problems here. But if I change this to something else. Like example here, just now I gave 20 31. If I give, this will not go, because if I give 21 elements in both the three lists, still I'll be left with some of the elements, but I can't add those elements inside another list because I have specified just 3. So this should be equally uh, once you so the best trick to know that will it go equal or not, just take this element and multiply with this element. If you get the answer this, then run that, then it will be equally divided. So this is all about reshape. Okay guys, so next thing is like example, when I view my ARR, run this. Here ARR is not yet changed, but just now I wrote the code and it's already run, but then to it's not yet changed. So why is it not changed? Because I have not yet put it inside a variable. If I put it ARR is equals to, now if I store it in a variable, now if I run it, then it's finally saved. But now if it was not saved before, here it was not saved because I was not stored this inside a variable. Until and unless you don't store in this in a variable, this will not be reflected finally. This is a kind of view. So until you don't change it, it will not be. Until you don't store it in a variable, it will not be changed. Alright guys, so at this point our array looks something like this. So it's a 3D array. Now if I check its arr dot shape, shape, so this is 3 by 33 as we have defined it here. But if I want to change it back to how it was normal, because now I have completely changed it, right? So if I want to change it, it's very easy. Arr dot ravel, and here I'm going to do a parentheses, and this whole thing again I should do the same thing which I had done here. I should put it in ARR. If I don't put it in ARR, so this will just kind of view, it'll be just kind of view, it will not be reflected. So okay, ravel spelling is wrong, RAVEL. Here I'm going to give dot. Run this. This is done. Now before it was 3 by 33. Now if I run this, it's 99. And if I view my ARR back, this is converted back to how it was before. Now if I again change, run this, this will be again, but again this here, repeat the process, and this will be back to normal. Okay guys, so the next part which we are going to discuss is axis, Numpy axis. The most important part of this whole video is axis. This axis we are going to use in Panda, Matplotlib, Seaborn and most of the libraries. So this is a very important concept. Now continuing from our PPT slide, the after download next part if we go is Numpy axis. Okay guys, so now let's discuss about the Numpy axis. So example, let me create a 1D array. So I'm creating a 1D array here. Next, let me create a 2D array. Okay, so we created a 2D array. Now what is this? This is a 2D array. This is a 1D array and this is a 2D array. So axis is kind of zeros and ones. So this we have just one. This is a 1D array. So here the axis would be, here the axis would be equal to 0 in a 1D array. I'll explain this in detail. Here 2D array and here the axis will be 0 and 1. So why is the 0 and 1? So the basic thing is, when we start in counting from in programming, we started from 0. This is the most important part. Now example, let me create a bar graph. Now you know the x and y coordinates when we draw a bar graph. So here we have a x and here we have y. So this is y and this is x. Let me change the color. So here in this 1D array, 1 2 3 4 and 5, So this axis, now if I want to represent this data in a bar graph, let me consider I want to represent this data. So if I want to represent this data, I need to, if I want to put it in a bar graph, I need to use just x-axis because there is just one dimension here. Now if there is just one dimension, representing the data in one axis will be enough. Just x-axis will be enough. So to represent this 1D array. So in this case, x has been converted into, in the case of Numpy axis, x has been created into 0, converted into 0, and y has been converted into 1. So instead of saying that this is x axis, we can say 0 axis, and instead of telling y, we can say 1 axis. So here to represent, let me change the color again. So to represent 1, 2, 3, 4, 5 for 1D, here if I want to change it, here I need to represent, I can represent this at 0 axis only. That will be enough because it's a one dimension. But here 2D arrays, here I have different types of data. Here I need to represent with different types of axis. 0 axis won't be enough. We need even y axis and x axis, which is 0 and 1, both axes, to represent this data. Like you can see here, we are using one axis. Example, this is one list. So this list is here. So this list will represent even y axis and x axis. So I need one x axis and y axis both to represent 2D data. Okay, so one basic example if I give, let me change once more the color to white. So here if I give a very basic example, let me let me explain it 2D once. So here if I write 1, 2 and 3, 4, 5 and 6, 7, 8 and 9. Okay, so let's take a little bit short numbers, but a little bit small numbers. So if, let me erase this 8 and let me erase this 9. Some small numbers would be best for smaller calculations. So I'm going to take 1 and 0. These are some small numbers. And here I need to change it as well. Let me erase this and this and change it to 1 and 0. Okay, so if I tell this in a form of x-axis and y-axis, so this will be in the form of x, and this will be in the form of y. This will be y-axis, this will be x-axis. Now x-axis here, as we have discussed, x has been converted to 0 and y has been converted to 1 axis. So this is the form. Now if I want to do operation on axis of here, let me just put it y-axis. Now if I remove this x and y, just simple, let me give, this will be 1 axis and this will be the 0 axis, this 1 and 0 axis. So now if I want to perform tasks at 0 axis, at 0th axis, if I want to perform the tasks, so to perform the task at that, so this will be example row 1, like that, row 1, let me put the 0 a little bit far, row 1, row 2, row 3. So here if I want to perform the task at 0 axis, let's consider summation. So I need to do summation of 0 axis. So 0 axis is kind of straight axis, this, and 1 axis is going in this manner. So if I want to do summation at 0 axis, I need to count these numbers. Let me change the color. So if I change this 147, if I add it up, 7 plus 4 plus 1 is 12, and 5 plus 2 plus 1 is 8, and 6 plus 3 plus 0 is 9. So this is the formation of 0 axis. Using 0 axis, if I do summation, I'm going to get these answers, but it's completely different for 1 axis. 1 axis, if I start doing addition and subtraction, so addition, let's consider 6, 3 plus 2 5 plus 1 6, 6 plus 4 10 plus 5 15, and 7 plus 1 is 8. Now you can see this is completely different numbers here and there. 0 axis there is a different answer, 1 axis it's different answer. So this is how you can perform tasks at 1 axis and 0 axis. So this is the basic idea of Numpy Axis. This is a very important concept. This we are concepts we are going to use even in pandas, matplotlib. So this is very important. This ID, 1D array, 2D's array, and this x-axis. Hope you have understood. If you did not understood, again watch this part. Again, if you watch it twice, thrice, you'll understand the concept easily. Okay guys, so now we are going to practically discuss about Numpy Axis. So the same 2D array which we created, that I'm going to take it as an example. Let's name it as x is equals to, and here I'm going to pass along the same data which we wrote there, 1, 2 and 3, and here 4, 5 and 6 and 7, 8 and 9. Okay, not 8 and 9, 1 and 0. Okay, these were the data which we just passed along. Now I'm going to create a numpy array np dot array, and I'm going to pass along the x list. Run this. It's been created, our matrix or array has been created here, matrix. And then here what we are going to do is the same thing which the x axis and 0 axis things we did there. The same thing we are going to do now. ar dot sum, here this is the function sum axis equals to 0. Run this and you're going to get totally the same answer, 12, 8 and 9 which we discussed. This 12, now this will scan. Now what will this do? This will go to the each and every column. 0 axis we know it's columns, so it will go to the each and every column and scan through the columns, and whatever function we have said it to do, it will go and do. Now if I just run this, instead of 0 if I put it 1, run this will be the same answer which we discussed. Again this axis is equals to 1 will just scan along the rows. First row it will scan along, give the answer, then second, third, and it will going to just sum the functions. So hope you have understood the numpy. If you have access, if you have not understood the numpy axis, watch it twice, thrice, how much ever times, but please understand this, because if you don't understand these numpy axis, so this will create a problem if you are doing data visualization in matplotlib, or mathematical problems in numpy itself or in pandas. So basically Python has some attributes, built-in attributes and functions which we can use for better analysis. So first thing is flat, ar dot flat. So if I run this will give me a iterator, and then if I give for item in ar dot flat, and here if I pass along print item, run this will give me all the elements, pick all the elements from ar, this. So it'll pick each and every element from it and print it one by one. It'll generate a iterator as well. So second thing is transpose ar dot t, run this will transpose, all the columns will become rows, rows will become the columns, just opposite. Then next thing is enddim, ar dot enddim. If I run this will give me 2. What is this 2? There are 2 dimensions. This is a 2D array. Next thing is ar dot size, which we have discussed up, 9. Next thing is ar dot n bytes. N bytes. N bytes do. N bytes will actually tell how much bytes does this array is taking. It's taking totally 72 bytes. Functions and methods. So now these things are functions, but this is like example np dot argument max, and this if I give parenthesis, this becomes a method. So this is not a function, this is a method. Difference between functions and method: function and methods do almost the same thing, but to find whether it's function or a method, functions doesn't have a parenthesis, methods have it. Argmax, if I here I need to write AR instead of NP. AR dot argmax. Here 6 I'm getting. So 6 is what is this 6? So this 6 will actually, let me just remove this is a 2D array. This is a little complicated. I'll create a np dot array and here I'm going to pass along a 1D array. Let me give 1 3 4 and let me give 2 3 4 and then 2. Run this, and now if I check 1 uh, 1 dot argument max and run this will give me 3. So 1 2 3. Okay, so no, 0 1 2 3. At the third index of this array there is a argument, there is a, this value is big, max element in this whole array. In this whole array the biggest element is at third index. So this is what argmax does. Next thing is 1 dot argmin, and this will basically give 0. Index 0 means 1. At 1 this is the minimum value. There is nothing smaller than 1 in this array. Next thing is 1 dot argument sort, arg sort, and this will sort the element if I in ascending order. Now at 0th element it's 1. Now at the 4th element it's 4th index there is 2. Then at the first element, first index there is 3. So now if I put this in this order, if I create an array, this will be in ascending order. This is just for ascending order, nothing else. So this is all about arg sort. Okay guys, so now we are going to discuss about the 2D arrays. Here array of the 2D. So here I'm going to, for 2D arrays they almost the same thing. AR dot argument min will just give the minimum value 8. First let me print AR for confirmation. 0 1 2 3 4 5 6 7 8. Eighth element this is, so it's the least element, which is minimum element. There's nothing small than 0 in this array. So then argument dot max, if I do, okay, here AR dot max, and here sixth, 0 1 2 3 4 5 6, here 7. So 7 is the largest. There's nothing big than 7 in this array. So next thing is, using axis we are going to find out the sort. We are going to do arg dot max and sort. So AR dot argument max, and here in the parenthesis if I pass along axis, okay, here pass along axis is equals to 0. Run this will give me 2 1 1. Okay, so what do I mean by this? So if I go to this array, 0 means these columns. So 0 in this first, we'll take the first column, which is the biggest element. 0 1 2, second element index, print it here. Let's go to the next column. 0 1, this is the biggest one, let's print it. Next 3 6 0, which is the biggest one, let's print it here. So this is how we did for AR dot argument. Okay, let's okay. So if I change this to axis is equals to 1, instead of scanning through columns, it will scan through rows to 0. So it'll go to here, which is the maximum. 0 1 2, this one is maximum. Then 0 1 2, then this is the maximum again. 0 1 0 2 0 1 2. So here 0 is the largest element. So this is how for our max using axis. Then next we are going to do with sort. AR dot argument dot sort, and here I'm going to pass along axis is equals to 0. So if I pass along 0, this will give me in this way, it will be sorted 0 2 2 1 0 0 2 1 1. So 0 2 2, means if we do it in a correct way, first thing will be 0th element, like this it's going to sort it. And if I convert this into this here 1, run this will be 0 1 2 0 1 2 2 1 0. So just opposite of these. If access 1, it will just scan through the access 1. So these were some basic kind of functions and methods provided by NumPys. Now we are going to discuss about the mathematical operation provided by NumPy. Okay, so now if I go along with some basics mathematical operations. So example, I print AR, run this, and this is my AR. And next, if I create AR2 equals to, we copy this and paste it here, np dot run this and check in my AR2. So this is changed, but little bit of couple of changes let me do for better mathematical calculations, because I need to recheck it. So if it is a small number, it would be much better. We change this to 0, and let me change this a little bit big so that calculations are not too easy. 8 1 and 0, run this. And now if I do AR plus AR2, run this, and this will be, you can see it has been added. What does this do? Now it picks first element from AR 1, first element of AR2, 1 plus 1 2, put it in this. Then second element picked, then here 4 plus 2, then it's 4 2 plus 2 4. So now if I add this to a3 inside a3, run this, and then if I view a3, so this will be all inside a3, addition of AR plus 2 AR plus AR1 plus AR2, this will be added inside the variable. But for now let's just do the basic mathematical operations. Same for the multiplication. If I just change this to multiply, run this will be multiplication. 1 times 1 is 1, 2 2s are 4, and 3 times 1 is 3, 4 times 4 is 16, and this all goes on for all the operations. But what, like many people will ask, like why can't I use just simple list? But list does not provide you these functions. This is why we use NumPy. Now if I create a list, example, let's take 3 4 5, and here I'll put another element 1 2 3, and if I plus it and put another 7 8 9 and 5 6 7 and run this will kind of extend the list. No, it will not like be like adding the first element and second element, not like that. It will just extend the list. So this is why we use NumPy, because it provides efficient storage plus mathematical operation is the best for mathematical operations. So next thing is a square root. So numpy dot sqrt, numpy dot square root, and here I'm going to pass along AR. Run this, first element it's square root, second element it's square root, all the elements square root will be printed for you. So AR dot, next thing is AR dot sum, run it, it'll take all the elements, add it up. AR dot maximum element, okay, so here I need to give this here 7, and then next thing is AR dot min, x AR dot minimum values, okay, again this 0. So these are some kind of example of mathematical operations. Next thing is if you want to access some element, so here we need to write numpy dot where, and here I'm going to write AR and then the sign 5. Run this 1 and 2. So if we'll go to AR, we'll just go to AR and find the number things which are less than 5. So it's 1 2 2 and 0 at the first. Okay, yeah, this 1 and 2 and 0 is given the indexes. So these were some kind of examples of mathematical operations and dot where. So in the starting of the video I have already explained about how it takes less bytes numpy, but I did not give a accurate and a best example. So a best example is like if I import sys, it's a package which automatically comes with anaconda. Now if I create a python arr, which is a array, and here if I pass along some couple of values 0 4 55 and 2, run this, and here if I write numpy array, both are different. That array is created by python and this array is created by numpy. So here if I put numpy dot a array, and here if I write py underscore array ar, okay, numpy dot ar I should give, and np dot array and pyarr I am writing here, so I should give this like this. Okay, so next thing is that sys dot get size of 1. There's just one array multiplied the length of this array. Now I should multiply this so that I can get the accurate result. Here you can see 112. So python array which I created here, this python array takes 112 bytes. There's just 0 4 55 and 2, just this four numbers, one digit and one two digit numbers. This is just taking 112 bytes. But if I just write it in numpy underscore ar dot item size, this is a same. Now this is both are same, but that is used for python and this is used for numpy. Item size times np underscore ar dot size. If I run this is taking 32 bit. Now you can see 112 bits and 32 bits. Where is 112 bits? 112 is like it's taking more bits, not even 64 bits, taking 112 bits, and here just 32 bits it's saving almost, and the same value, not values are not differing here. Here it's taking the data from pi underscore r, so the numbers in this numpy underscore array is the same 0 4 50, 55 and 2. So this is kind of one great example which can tell you that python array takes more space compared to numpy array. So this is why we use numpy, because controlling the memory is much easier in numpy. Okay guys, so now we are going to discuss about some attributes and uh, methods through some documentations. Head over to Google and search for numpy array attributes and methods. You're going to get from numpy.org. Hit enter, scroll down a little bit, and here you'll get some attributes. Now main ones I have already covered: dot t, dot d type, dot size, item size, n bytes. These I have already explained. Dot shape, easy. These are easy ones. And here a couple of methods. So I request you all to just try one each and every like try to do each and every methods how much ever it's possible. Example, like you can go example, I need a to list. There is something called as to list. Okay, here this to list, I'll click here, and here they have explained it in a great detail here, and with some examples are given here, 2 to 3 examples. So this to list is just a brief information. This to list will actually convert your array into a list. That's simple. So here this will be explained here in a great detail and some couple of examples. So this was the documentation. You should I hope you have understood. You should try each and every thing. um, because this we are going to use in the practical project section as well. Okay guys, so the next topic which we are going to discuss is random method. So random method is used to generate random matrix or array. So for this you need to know two basic things, which is uniform distribution and normal distribution in maths. So if you are familiar with algebra, so you must be knowing uniform distribution and normal distribution. So let me comment this out. So first we are going to discuss about the uniform distribution distribution for random method. So uniform distribution, so we are going to find it between bit here we need to give between 0 and 1. So uniform distribution between 0 and 1. So how can we do that? So in order to do that, create a variable x and here put np dot random dot rand. So if I want to do uniform distribution, you need to write np dot random dot rand and here specify how much numbers you need in your array and then print x. Run this. So you're going to get random 10 numbers here between 0 and 1. So here you can see these are the random numbers between 0 and 1. So like this you can even create a matrix as well. So let me copy this code and paste it here. So if I paste it here and do a couple of changes, example 10 cross 10, run this. So this will become 10 cross 10 matrix. So 10 by 10 into 10 is 100. So there are totally 100 elements in this. So this created a matrix. Now it doesn't looks like matrix because here this lists, because it's 10 by 10, so 10 numbers can't be fit in just one line, so that it's not looking correct matrix. But actually if we convert it into matrix, so it will look 10 cross 10 neatly. So the next thing is normal distribution. Now we discussed about the uniform distribution, so the next thing is normal distribution. So this also we if you are familiar with linear algebra, this is a very important topic, normal distribution. So if I create a variable which is y equals to np dot random dot rand n, and here if I give out 10, if I give out 10 here, and if I ask it to read this here, enter, and if I ask it to print y and run this, so this will give you a normal distribution. So normal distribution I have already discussed, np dot random dot rand n. So here the difference between these two is n, just n. So here rand means it will do uniform distribution, and if you just add a n, that means normal. Rand n, rand normal. So this will do normal distribution in numpy. So next thing is rand int. So rand int is it's another important concept. So we are going to use this in a practical project as well. So here rand int. Now rand, as you know, this is for distribution, and int means integers. So it's used to generate a random integers with a between upper and lower bound. So we give a upper bound and a lower bound, so it's going to generate a random number. So if I make a x variable and store np dot random dot randint, and here if I put 1 comma 10, here if I give 1 comma 10, so this 1 comma 10 will it's kind of with between a lower bound and then upper bound. So this lower bound will be equal to 1. So here if I comment it out and write 1 equals to lower bound and 10 equals to upper bound. So this is lower bound and upper bound. So 1 will be the lower bound, 10 will be the upper bound. So between this, any one number it's going to print. So if I print x and run this, so this is 1. If I run this again, it will be 4. So again, how many times you run, you will get every time different answer. Not going to get the same answer. You can see here 5 5 7, then 5. So it will just be printing random numbers. So with the lower bound of 1 to 10. So next point is kind of same, but we are going to give a space. So let me create a variable x equals to np dot random dot randint, and here I want to give 10, 100 and 15. Alright guys, so what will this do? Random dot randint with this. So this is kind of lower bound, this is the upper bound, and this is how much numbers you need in total. So here if you don't specify, it will give a random number. Once again, if I run it once again, so that I get another number. Okay, 9 here. These are just random different number, but it's just single. What if you want between 10 to 100, any 15 numbers? So even these numbers will vary each and every time because you're generating it randomly. So again, it's changed, it's randomly generating. So every time you run this, you'll get different numbers because you have a very big range. Here you have a very short range, so numbers are repeating, but here there are totally 15. There are lots and lots of possibilities of getting different types of there are totally 15 square possible times that you can get different numbers here. So you can get every time different array. So these are random numbers. So random, you can just specify 12's value, 84 value, or different values. Or if you want to work on a sample data, so you can use this for random round randint and give some specified. Here what it does is normal and uniform distribution between 0 and 1. So between 0 and 1 only it does the uniform and normal distribution, but here it takes integers. Most probably it takes positive numbers. Okay, the next thing which we are going to discuss is I in numpy. So let's take example wherein x is equals to numpy dot I. So this is a method which is used, and if I specify here 5 and view my x, so this will be an matrix of 5 by 5 as we defined it here. 5 by 5, 1 2 3 4 5, and here 1 2 3 4 5, 2 3 4 5. Yes, so here I, what it will do, in most of the programming language you can find this I function in C, C++, Java also. So what will this do? Like example here, all if you take it in an easy manner, so everything will be 0, but the ones will be in the form of diagonals. Here it's a diagonal, and for here it's diagonal. So here you can see in this axis, at the 0 axis, first 0th element is 1, and here at the first element, here at the second element, here third, and here fourth element. So this is how it works. It's kind of, you can think of a diagonal ones. Next thing is, now here we discussed numpy dot ones, and we discussed our numpy dot zeros. So there's one more thing here which is numpy dot ones. So what will this do? Just print once. If you recap the intrinsic creation of numpy array, so there we have discussed about np dot 0. Now we are going to discuss about the ones. It's kind of same. Example, if I give 5 and then if I view my x and run it, so here 1 1 1 1 1 2 3 4 5 5 ones are been printed. If I do it 15, so this will give me totally 15, 1 2 3 4 5 6 7 8 and so on. So next thing is matrix of 1. This is also kind of same thing. X is equals to np dot ones, and here we need to specify how much by how much. So here example, if I give 15 by 15 and view my x, so this will be 15 by 15 once, just one here. Here there are totally 15 numbers. ones here, totally 15 ones. So kind of matrix. So if I check my x dot shape to check whether it's actually 15 by 15, so it's 15 cross 15. So this is what example of ones and zeros in intrinsic NumPy Python creation of objects. So the last thing which we are going to discuss today is broadcasting method. So if I create a variable x and put numpy dot random dot randint, which we just now discussed, and here if I give a lower bound of 1 and upper bound of 10 and total 10 values and view my x, so here are the random data. So if I do x and here if I write 3, so this will give me first three third index. So this is 0 1 2 3, third index is 6. And then if I give x and here if I give 0 and then if I pass 3, this will give me 0 1 2. So between 0 and 3 whatever numbers comes, which is 7 2 and 8, so those numbers will come. And next thing is okay, so now let's come to the point, which is broadcasting method. So broadcasting method is altering several values in a numpy array at once. So what do I mean by this? So if I create x 0 and here if I do 6 and here if I do equal to, okay, here if I do equal to 10, but and enter an x and run this. So from 0 till 6, the every numbers from 0 to 6 will be converted into 10. This is 0 1 2 3 4 5. So it's up to a 0 1 2 3 4 5. So it's up to and excluding again. So here's this many numbers are converted to 10. Now if I pass to 20 and run this, so this will be 20. Rest of them will be the same thing. So this is all about the broadcasting method. So now that's end our NumPy tutorial. From basics we started how to import NumPy, creating an array, then array creation methods, and then NumPy Axis. I explained this through PPT slides, and then random method, and then broadcasting method as well. Now this completes our NumPy section, NumPy library. So now understand these things you need to know. You have to have a knowledge of Python. So for that I have in my channel, you can see all the Python videos till functions. I have explained each and everything in a great detail, so you can just go and watch out the videos, all the videos, because these are very important while using NumPy. So I recommend you to watch each and every video. So these all everything are important when you go in a detail of NumPy. So you need to watch this all the videos. So that is all for today. Hope you enjoyed this video. If you did, make sure to like this video, and I'll catch you guys in the next video. Until then, goodbye.